using long division. Integration using long division. If you guys check this out on the AP College Board, I haven't been assigning the videos as often as I could, but you guys can check this out on your own time. They're all there. This is one that is up there as well, and you can see how to practice with this. Now, sometimes when you're doing your integrations, U substitution is great, right? But sometimes U substitution doesn't quite work all the time. So for example, if I have something that looks like this, the integral of 3x cubed plus 2x plus 5 over x squared plus 4. Whenever your numerator has a power that's bigger than the denominator, if the degree of the numerator is greater than or equal to the power or the degree in the denominator, you don't need to do U substitution. U substitution is great, but you don't have to always do it. In this particular case, if you actually tried U substitution and you let U equal to 3x cubed plus 2x plus 5, and we found out that du is equal to 9x squared plus 2 dx. This right here will not cancel out with this, by the way. This here right here, when you substitute in, it will not cancel out with this. If you do this, you end up with the integral of u over x squared plus 4 times du over 9x squared plus 2. And look, this right here, they don't cancel each other. They're both in the denominator, and this doesn't match up with this one. It doesn't have a factor of that one. So U substitution does not work in this case. But since the power in the power in the numerator is greater than or equal to the power in the denominator, we can do long division. Do you guys remember long division? Some of you guys might not have learned long division, and I'm going to teach this to you right now. Right? Long division, if you remember back in from, actually, you guys might have been students of Common Core. Do you guys remember long division? Did you guys ever have to learn this? Like, let's say I was asked you to do the division 37 divides into 5,386. Do you guys remember how to do long division? And you're like, yes, knock me, yes. Okay. So you figure out what multiplies with 37 to get to here, right? We multiply it, and then we subtract that, and then we do this. And 6, 1, and then you bring down the next term, right? And then you repeat until you can't do that anymore. When you have a degree here that is greater than the degree in the bottom, you're allowed to do long division algebraically. So I can rewrite this thing. I can rewrite this using long division. You ready? So here's the long division. Let's do the long division. So I'm going to go ahead and put what I'm dividing by. So just a quick refresher, this would be the same thing as 55,386 divided by 37. That's how long division works for that setup. So over here, we're going to do the same thing, but we're going to do it as x squared plus 4 dividing into 3x cubed plus 2x plus 5. All right? So we're going to go ahead and do that. And I'm going to figure out what should I multiply x squared with to get 3x cubed? And all I need to multiply that with is, well, 3x, right? If I multiply 3x times x cubed, right, I end up with 3x cubed, right? That's me multiplying here to here. And then I multiply that with the 4, and I'll end up with 3x times 4, which is going to give me plus 12x, right? That's normally what we do here. We'd multiply the 1 by the 7 and the 1 by the 3. That's how I got this 37 down here, right? If it was a 2, I'd multiply 2 times 37 and get that number down there as well. All right, so this next one would be like for example, this would be like, what would be 4? Yeah, if I multiply this by 4, it would be 4 times 37. 4 times 7 would give me 28, carry the 2. 4 times 3 is 12, plus 2 would be 14. And I would subtract that. So I would multiply this 4 to this one right here and this 3. That's what I'm doing with this 3x. I'm sorry if I'm rushing through this. Then once you multiply that, I'm going to go here and subtract this from that problem in there. So I would subtract the 3x cubed minus 3x cubed. That goes away. 2x minus 12x is going to give me a negative 10x, right? It's going to give me a negative 10x. And then after that, of course, I just bring down my plus 5, right? And now there's nothing I can multiply x squared by to get to that 10x, right? To get to that 10x. So this right here is a remainder. Now, with remainders, with long division, we would just usually put an R and then put the remainder at the end there. Now, if you learned it more recently, the remainder is whatever that number is divided by whatever that you had to begin with. So if you had your answer, this was like, let's say it was 140 something, 145, and then the remainder would just be whatever you get as your leftover, whatever that is down here. I should have did this number earlier. So this is 2, 0, bring down the 6. How many times is this going to 206? 5 times maybe? Yeah, let's go with 5. 5 times 37 is 35, carry to 3, 18, 1, 1. So here, the remainder would be 11 over 37. Over here, this remainder is going to be negative, I'm sorry, it's not negative, is it? It's going to be plus a negative 10 plus 10x plus 5 over x squared plus 4. So this right here, what I've done essentially is I figured out a way that I can rewrite this fraction as this one right here, simplified using long division. Now you'll say, why do you care about rewriting it like that? Well, I couldn't integrate it using use substitution up here. So integration was not going to work, and they asked us to integrate this. So if I can rewrite it into something that will help me integrate it, I'm going to go ahead and try that. So I'm going to go ahead and rewrite this fraction I had up there, right? Instead of writing it as the integral of 3x to the third plus 2x plus 5 over x squared plus 4 dx. I'm going to go ahead and rewrite this as the integral of 3x plus negative 10x plus 5 over x squared plus 4 dx. Now, remember, properties of integrals. If you have a plus sign in there, you can separate them apart. I couldn't separate these plus signs because it's part of a fraction, right? I can't just break up fractions that easily like that. I can't just break that up into 3 separate fractions and hope that it works. So instead I did this right here. Now I'm going to rewrite this as the integral of 3x dx minus, right, the integral of 10x over x squared plus 4 dx plus, and then I'm going to break this up right here, the integral of 5 over x squared plus 4 dx. So I'm just splitting this up so I can handle them piece by piece, right? Now, why the minus? Oh, sorry, I should have showed that. That minus is this minus right here. Don't be lazy, knock me. Okay, I won't be lazy. I'm sorry. Thank you for asking that question, Monica. Oh, wait, never mind. It's a plus and then there's a minus right there. I got lazy and I should have showed that step. No, Monica, don't never mind. That's a good call out. I shouldn't be lazy. I should show my work. Sorry. Okay, let's keep going, right? Now that I have these integrals broken up, it's a little bit easier to deal with than this guy, right? I can't do use substitution, but I can do these integrals right here. And this one's probably going to use use substitution right here for sure. So let's go ahead and do this. This is going to be 3x squared over 2, right? Plus this integral right here. I need to do that. I think I definitely need use substitution for that one. So for this one right here, let's do this one in blue right here. Let's do this off on the side. I'm going to let u equal to x squared plus 4. I end up with du is equal to 2x dx, which means that du over 2x, is going to equal to dx. I can replace that right there. This is going to become the integral of negative 10x over u, and instead of dx, I'm going to write this as du over 2x. So what's going to happen here is the 10 and the 2 is going to reduce down to a 5, and then the x's will cancel out. So when I do that integral, there's a minus sign right there. This is going to become minus 5 times the integral of du over u. Okay, so that's that one. That's what that one's going to become. Let's do the next one over here. In red, I don't think that's going to use use substitution. Instead, I'm going to take that 5 out and write that in front. And then over here, I'm going to have the integral of 1 over x squared plus 4 dx. And if some of you are familiar with this, this is very similar to, let's do this in red over here. This is very similar to the integral of 1 over x squared plus a squared dx, which is arctangent. Very good, Monica. Now, our a in this case, right, our a squared in this case is 4, which means a is equal to 2. So if you have this, let's go look at our cheat sheet real quick, just in case we don't have this memorized, right? Let's go look at our cheat sheet. Boop. And where is it? Knock me. Integral formulas. Let's look for the one that looks like the arctangent with the a right there. And it's right there, right? It's 1 over a arctangent of x over a. So this right here, when you integrate this, a is going to be 2. So this right here is going to be plus 5. Huh, interesting. Oh, wait, no. Yeah. Plus 5 times 1 over 2 times the arctangent of x over 2. Right? This is equal to 3x over 2 plus all that. Let's clean this up. Let's make this look a little bit nicer here. This is going to equal to 3 over 2x squared minus this right here is going to be the ln function. So it'll be 5 times ln of the absolute value of u, and u was equal to x squared plus 4 plus 5 over 2 times the arctangent of x over 2. And of course, when you do these integrals, you need to remember plus c. It's not pretty, but it works. So it is just another technique. Long division is something that can help you rewrite this so it's easier to deal with. You try to simplify it before you kind of do it there. I know I kind of rushed through this one. I believe on your tests, you might have a problem like this, but I wouldn't stress out too much over it. It's just another technique. It is on your study guide, so you guys could try it on your study guide. Let me open up your study guide here. Are you zoomed out? You okay there? That's good. So on your study guide, it's number 3 on there. It's number 3. So you guys can practice that. I think that's the only one that has long division on there on your study guide. Your study guide here, it looks like there's going to be a total of 13 problems. Yeah, 13 problems. And yeah, you guys can get that on there. And I think that's going to be it. If you have any questions about your study guide, if you have any questions about Delta Math, tomorrow is going to be just all review. So in class, we're just going to review. I'm going to do problems with you. If you have any particular questions, if not, then I'm going to have I'm just going to give you time to do these questions in class tomorrow. That's pretty much it. I want you to work on them. I want you to ask questions on them with me. And yeah, I think that's going to be it. So hopefully you're okay with the long division technique of doing this. There's another technique, and I'm not really going to, I mean, I'll show it to you. It's another technique, and it's one of those ones like it still scars me to this day. Let me just write it out. It's called completing the square. Completing the square is another technique that I don't know why I have such a, not an aversion to it, but just like, what's the word I'm looking for? Raw hatred towards it is what I have. So yeah, actually, you know what? I'm gonna write this example down. It will be recorded, but don't worry if you don't understand it. It was here. Just check this out. So check this out here. If I have here the integral of 1 over x squared minus 4x plus 7, right? Dx, right? You can't do u substitution with this because if you try to let u substitution as x squared minus 4x, right, it's not going to work out, right? Watch, if we let u equal to x squared minus 4x plus 7, I end up with du is equal to 2x minus 4 dx. And when you do the u substitution, since this is already in the denominator, this doesn't cancel out with anything. You're just going to be left with the integral of 1 over u, and then you'll have here du over 2x minus 4. And u substitution doesn't work because now you still have an x term in there, right? And it just makes it messy. So instead, for completing the square, you rewrite this as squared forms. Have you guys ever learned about completing the square? You can make it into a factored form of something squared. So this right here, you can rewrite it as 1 over x squared minus 4x, and then you space out the plus 7 right there. You decide to add and subtract a number in. So you take half of this number, square it, and then add it to itself. So this will be 4 over 2 squared. But when you add that to something and you subtract it at the same time, you're technically not changing your fraction. And this is what I mean by I was kind of emotionally scarred when I learned this. I was like, why would you do something like this? And the reason is when you do this, sometimes when you rewrite it, you end up with something like this here. We'll have here x squared minus 4x. This is going to be plus 4 over 2 is 2 squared. 2 squared is 4. Plus 7 minus 4. Now check this out. What happens here is this is the weird part. If you group this right here, this is a perfect square. That's why it's called completing the square. You've completed this perfect square, which you can then factor and rewrite this as x minus 2 squared. Because if you factor this out, this will be x minus 2 comes out as x minus 2 squared. Plus 7 minus 4 is going to give me a 3. And believe it or not, oh, there should be dx's along the way here. Believe it or not, this right here is actually the arctangent. I don't know if you can see this or not, but this right here is like your x squared, and this right here is like your a squared, right? I kid you not. It's freaking weird. So this is like saying u is equal to x minus 2, and this is saying a is equal to the square root of 3, right? And if you were looking at the back at the other form of the integral using arctangent, this would be 1 over x squared plus a squared, right? Or instead of x squared, let's call it u squared du. So this would be 1 over a times the arctangent of u over a. That's what's happening here. U is equal to x minus 2. A is equal to the square root of 3. This integral, thanks to that completing the square, is going to become 1 over the square root of 3 times the arctangent of x minus 2 over the square root of 3 plus c. I'm sorry I kind of rushed through that, but we're short on time, and it is 10:15. Don't worry if you didn't get this in one go. It's just like one of those things I just threw at you right now. But it is a technique that you do need to. I don't say you necessarily need to know it, but it is one that it helps if you know it. Anyways, we'll talk more about this tomorrow. It is 10:15. Go ahead and head off to your next class. Thanks for listening to me like throw a shotgun problem at you guys. Have a good rest of your day. I'll see y'all tomorrow. Come in ready with questions from your study guide, from Delta Math, or else it'll just be awkward. I'll just be staring at you for an hour and 15 minutes. Have a good rest of your day, everybody. So long. Farewell. Bye-bye, everybody. Woo.